So let us continue with our discussion on spanning tree priority. But before that, let's just have a recap of what we discussed yesterday. So we started looking into the a practical of the whole spanning tree scenario, right? And then we discussed about BPDUs, Bridge Protocol Data Unit, and basically Bridge Protocol Data Unit is a PDU or a protocol data unit which is sent by any spanning tree speaking switch, right? So whenever a switch is powered on, it sends BPDU, that is spanning tree BPDUs, in which these few things are the main contents. So it tells about the route switches priority, it tells about route switches MAC address, it tells about advertising switches priority, it tells about advertising switches MAC address, what does it cost to reach the route switch, etc. Along with that, it also tells about the hello timer, dead timer, and the forward delay timer in the BPDU. Now, with these five things, priority, route switches priority, route switches MAC address, advertising switches priority, advertising switches MAC address, and the cost to reach the route switch, they decide the switches in the spanning tree network. They decide who is going to be the route switch and who are going to be the non-route switch, and on the non-route switches, which interface will become the route port, designated port, block port, etc. based on these five factors in the BPD. And this is what we had learned yesterday. Now, continuing with our discussion on the timers. Okay. So we discussed BPD last night, BPD, Bridge Protocol Data Unit, which is sent or generated by the route switch in every 2 seconds. In every 2 seconds of interval, the BPDU is generated by the route switch. Okay. And when the route switch creates or generates this BPDU, it is forwarded by other non-route switches to different other non-route switches. Okay. So a non, like in this diagram. Okay. So the BPDU is generated by BPDU is generated by switch number one, right? In every 2 seconds of interval, right? And this BPDU is then forwarded by other switches. Okay, it is then forwarded by other switches to other non-route switches, and that is how the BPDUs propagate across the whole network, right? So as I said, BPDUs are generated every 2 seconds of interval, and it is generated by only the root switch. No other switch will generate the BPDU. It is generated only by the root switch. Okay. So this 2 seconds of interval is called as your hello interval. It's called as the hello interval. Okay, which is 2 seconds. Okay, and this is the default timer. This is the default timer. Since it is a default, you can change this timer as well. You can either decrease it or you can increase this hello timer. All right. Now, then there is something called as a dead timer. Okay, dead timer, which is basically three times, the hello interval. So 3 into your hello interval, which basically is your 6 seconds. Okay, this is your uh, dead timer. Okay, meaning that if for 6 seconds it does not receive, if a switch does not receive a hello message, or it does not receive a hello from its neighboring switch, it considers it the neighboring switch as dead. Okay, so for example, switch 1 and switch 2. Okay, these are two switches. Okay, so for example, this guy is the root switch, and okay, let me involve switch 3 as well. Okay, these two switches are non-root switches, non-root switch. Okay, so obviously, as I said, switch 1 will forward the BPD, and generate the BPDU, switch 2 will forward it to switch number 3. Now, for some reason, this interface goes down. So obviously the BPDUs will not be forwarded to switch number 3. So switch number 3 waits for 6 seconds. It waits for 6 seconds, basically one BPDU, second BPDU, and third BPDU. So 6 seconds, right? In total, it waits for 6 seconds. If it does not hear the BPDU from switch number 2 for 6 seconds, switch 3 considers switch 2 as dead, and it starts to look for an alternate path. It starts to look for an alternate path. It starts to look for an alternate path to reach the root switch. Okay, but as per this topology, there is no alternate path to reach the root switch. So we can assume switch 3 is isolated. Now, switch 3 is completely isolated. Right? If switch 3 had an alternate path, for example, and that alternate path is blocked for now. Okay, let's say switch 3 has an alternate path like this, for example, and this is blocked. This is in a block. This is a block port for now. And when switch 3 does not receive any BPDUs for 6 seconds, it considers switch 2 as dead. And what it will do, it will open up this block port. It opens up this block port so that now it is reachable to the root switch via the alternate port. This is the work of a dead timer. We'll discuss about unblocking of a block port in detail later, but this is the work of a dead timer. All right, any question?
So the S3, like suppose somehow it opens up this port, so it will send a BPDU, or it will again open the port and wait for the BPDU to come from the root switch.
Okay, so root switch is sending BPDUs through all the interfaces that it has connection to. Okay, previously, let's assume when everything was going well,
It was getting the BPDU from this port. Suppose the left side is F1 something.
yeah, and this is blocked. Okay, it is receiving BPDU from this side. It is also receiving BPDUs from this side, but it is choosing to ignore it because this is blocked.
Oh, it keeps on receiving. Okay.
It keeps on receiving, but because as per the spanning tree protocol, it is blocked. It
Okay, only the
receives
data
it.
is blocked. Only the data
Only
is
data
blocked.
is blocked. It receives BPDU, but it chooses to ignore, and it does not yeah, you can say it ignores it. It is receiving, but it ignores it. Okay, and when it stops ignoring it, when after 6 seconds, there is no reception of BPDUs from the other side. That is when it starts to listen to this BPDU that is received from the other side.
Other side. Okay, got it.
Okay, so that is the work of a dead timer. All right, now forward delay timer. I don't know. Interestingly, I am liking this pen stroke today. Forward delay timer. My handwriting looks better in this side.
Oh, in this
So
stroke.
yeah, in
Okay.
this stroke, my handwriting looks better. I don't know why. If I just write forward, yep, obviously.
This
My
one is
handwriting
better.
looks better.
This is better.
Yeah, this is better. Forward delay timer. Okay. Now to understand forward delay timer, okay, we need to understand few concepts. Okay. First concept is direct topology change. Direct topology change. Okay, this is the first concept that we need to understand. Direct topology change. Now, what is direct topology change? So please remember, whatever we are discussing right now is from the perspective of this switch which has a block interface. Okay, I'm repeating. We are looking at the topology or whatever discussion that we are going to have now from the perspective of a switch which has a blocked interface. Okay, so direct topology change, and we'll consider the same diagram with 4 switches. Okay, switch number 1, switch number 2, switch number 3, and switch number 4. Okay, and again, this is the root switch. Okay, if this is the root switch, this interface is the root port. This interface is root port. Okay, this guy, this interface, and this interface of the root switch is designated port, designated port, designated port, designated port. And for switch number 3, we'll have to find out which is the root port. So MAC addresses, obviously first for switch number 3, these two are root ports, but obviously only one of them can be a root port. Okay, so first is a cost cost to reach the root switch via this and via this interface, both are same. So the next tiebreaker is lowest MAC address of the neighboring switch. So 2 has a lower MAC address, right? So this becomes the root port and this will be a blocked interface. I hope this is clear. This diagram is clear.
Yes, yes.
Now, direct topology change. Okay, I shouldn't have. Okay, pardon my confusion here. Instead of bringing up direct topology change, I should not have brought this up, right? Forward delay timer. Okay, I'm sorry. For forward delay timer, yeah. Till now we learned about. We'll discuss direct topology change later. Okay, but for forward delay timer, we now know 3 different port roles. Okay, port roles. One which we have seen is the root port. Okay, root port, designated port, and then the block port. Right. These are the 3 different ports that we know. So these are basically port roles. Okay. Now, in order to reach these roles, the switch interface. Okay. These port roles are the interface roles, not the switch roles. These are interface roles. To reach these interface roles, the interface goes through different states. Okay, so these are port roles, and to reach these different roles, the interface goes through different states. Okay, before it lands in either of these roles. So the first state that an interface starts with is disabled. Disabled meaning that the spanning tree is not enabled on the switch. Spanning tree is not enabled on the switch. There is nothing present there. Okay, and it is basically not present. So everything is calm, cool, nothing has happened. Then the moment spanning tree is enabled on this switch, the interfaces, wherever there are connectivities, okay, wherever there are these things, what do you say, cables connected, wherever there are cables connected, what happens? Those interfaces, they go into a state called as listening state or listen state. Okay, in this listen state, what happens? All the interfaces, wherever there are connectivities, those interfaces which go into the listen state, they send BPDUs, they send their own BPDUs, they also receive BPDUs. Okay, they send BPDUs, they receive BPDUs. Okay, and the interface stays in the listen state for 15 seconds. An interface stays in this listen state for 15 seconds, and in those 15 seconds, it sends BPDUs, whatever BPDU it receives, or whatever BPDU it generates. Okay, it forwards those BPDUs. It also forward the BPDUs whichever it receives, and it is also listening or receiving BPDUs from other devices as well. So it stays in this listen state for 15 seconds. Once this 15 second has elapsed, the interface goes into a state called as learning state, learn state. Now in this state, what happens? the information that it reads or listened in the previous state. Okay, we know that in the BPDUs there are few information. And what are those information? Root switches priority, root switches MAC address, advertising switches priority, advertising switches MAC address, and the cost to reach the root switch. All that information is present, even the hello BPDU interval, everything. All that is present in the BPDU. So it has registered all that information. Now, with that information, whatever information it has listened, now it is learning those information. And after learning that information, the switch decides, is it a root switch? Okay. Is it a root switch? Okay. So if it is a root switch, all its port are going to be designated. Correct? Then if it is not a root switch, if it is a non-root switch device, it decides which one of its interface is going to be root port, which are the interfaces that is going to be a designated port, and which are the interfaces that is supposed to be block port. These things are
So it
decided in
is,
the,
so this is, it is, so it is learning now these things. So, but what it was doing, listening that time, was it is storing somewhere in the memory,
yeah, it was,
whatever
yeah,
is receiving from
whatever
that?
it is listening, it is just simply listening to it. It's just listening to the BPDUs that is being received for 15 seconds.
So listening,
Okay.
it will get lost, right? So it will listening, it will means it is storing somewhere. Then later it will start learning from that.
Yeah,
Or
you can imagine that when it is listening, it is also registering it into its memory.
okay, registering somewhere in memories. Okay, but
It's
then after
registering
that,
somewhere
when
in
it
the memory.
starts learning, okay, then when
It
it starts
starts
learning, it learns from that, from
uh,
those things what is stored before.
what is stored before, and based on that, it makes those decisions. Okay, is it
Okay.
a root switch? Is it a non-root switch, etc.? It makes those decisions.
And
Okay,
by that time,
and
more BPDs keep coming also, right? This only 50 second, 15 second, it will learn. By that time also, it will receive new BPDs also, right? Continuously.
correct. It will be listening. It will be receiving BPDUs in the learning state as well,
Okay.
but it will not send BPDUs. It will not send its own BPDUs.
Okay. It will, okay. Listening and learning state, it will not send anything. It will keep.
Right, right. So in the learn state over here, it will receive BPDUs. It will receive BPDUs, but it will not send BPDUs. It will not send BPDUs. It will receive BPDUs. Okay, and it will try to make new changes in the state. Okay, let's say there is a BPD when it was learning. Suddenly there was a BPD it received where, let's say that it assumed itself as a root switch for now. Then suddenly there was a BPD received where a better MAC address or a lower MAC address BPDU is received. So it needs to make that change quickly. If a lower MAC address BPDU is received, that means it's no more a root switch. It becomes a non-root switch. Then it needs to make the decision which of the interface will be a root port, designated port, block port, etc. All right. And in this state also, it remains for 15 seconds. It remains here for 15 seconds. Once this 15 seconds is elapsed, the final stage is again based if it is a root switch, what are the states? If it is a non-root switch, what are the states? If it is root switch, we know that all the interfaces are designated. The designated port state after learning is forwarding state. The forwarding state. All right. The forwarding state. In the non-root switches, we have root port roles, we have designated port roles, and then we have a block port. So root port and designated port are always in the forwarding state because they can forward data out of this interface. But a block port state is in a blocking state, is in the blocking state. So these are the four states that we will mostly see: disabled, listen, learn, and forward. Either it can be forwarding state or it can be a block state. If it is a forwarding state, it can be either a root port or a designated. But if it's a blocking state, then that means it's a block. Clear?
Yeah, it's clear.
Now, these 15 seconds in the listen and the learn state. This 15-second is what we call it as forward delay time. Forward delay time. This 15 seconds of time is what we call it as forward delay time. Again, you can change it. You can change it. This is a default timer. You can change it, but it's best not to change it. Let the spanning tree work as it was designed. Let's not change it. Okay. So
it is 15 second was only listening state.
listening and learning both.
Oh, listening. Oh, both
Listening also,
together.
both.
Oh, together is
Not
combined.
together,
Oh,
not together. No, no, no. Each listening
each.
state 15 seconds, learning state 15 seconds.
Okay.
So in
So
total, 30 seconds.
oh, total 30 seconds. Okay, that is total is the.
Okay. So for an interface to move from a disabled state to either forwarding or blocking state, the interface takes 30 seconds. Takes 30 seconds. All right. And that is what this 15 seconds of time in the listening state and learning state each is called as the forward delay time.
Okay.
It's called as the forward delay time. And this is what is sent over here. Hello timer, dead timer, and forward delay time. Hello timer, dead timer, and forward delay time. Hello timer of 2 seconds, dead timer of 6 seconds, and forward delay timer of 15 seconds. Which, as I said, is not needed to decide the different port roles or port states like root switch, non-root switch, root port, designated port, block port. All that election is not dependent on these timers. Okay, but in the BPDU, these timers are also sent. Clear?
But the block is that time we saw that it is happens after the root port selection, this selection, then after that only it goes into blocked or any state, right? It is blocking the port.
Okay.
So this block happens after it selects the root port, this designated port and all those selections, then finally it blocks the thing. But within meantime only this learning listening also is happening, right?
Yeah. So it's very quick.
So so, so
Okay,
that timer is
this exchange of
so
information
those
is very
timer
quick.
will be okay. So that depends on the timers also, right? Then it starts when we connect the wires. It starts the BPDU sending, and at that time only it keeps on selecting the root bridge. By that time only this dead timer, these timers also come into picture, right? Or it is
Yeah,
like
in the
separate.
yeah, in the learning state only, it decides which of the interface needs to be root port designated to block.
Okay.
It has decided in this 15 seconds. The switch has already decided in that 15 seconds which of its interfaces needs to be root port, designated port, and a block.
Okay. Then the in the UI it was
Uh,
showing like
yeah,
orange
yeah,
color or this thing got blocked. Okay.
correct. So the moment this 15 seconds of learning state is elapsed, it will immediately move those respective interfaces to their designated root.
Okay, designated one will become root port, one designated port, and one block
Yeah,
port. Like that will come complete
correct.
after this 15 seconds. Okay. That
Yes,
means total
yes,
30 seconds. After total 30 seconds, it will be done.
correct, correct,
Everything.
correct. So not just the whole network, each and every switch interface here, each and every of these switch interface, they take similar time. 30 seconds probably. Switch one may decide its states faster than 5 because to reach or to send these BPDUs and to make those decisions, fifth switch may have taken more time because to send these BPDUs, okay, and to receive different BPDUs from other switches, switch number 5 would have taken more time to decide. But eventually it will be decided. Eventually it will be decided.
Then one more doubt came. So
Hmm.
if it is 30 seconds, it will not
Hmm.
be 30 seconds for everybody in this to change its ports.
Everybody,
And
everybody,
within
every
30
switch.
seconds only, suppose this is a 50 switches network, it's not a 10, the 50 switches network. Okay.
Hmm.
And then it started the timers, So if within 30 seconds, each of them doesn't change the state. If somebody
No, no,
takes
no.
more
See,
time,
see,
somebody takes less
50
time.
sec 50 second is not for
50
the
switches,
whole
no, 50
network.
switch, no, 50
Yeah,
switches, I'm telling.
yeah, 50
50
switches,
switches.
50 switches,
uh,
50 switches. That 30 second is not for 50 switches. It is 30 seconds for each switch.
each switch.
Each switch. So each switch takes its own sweet 30 seconds of time.
Okay, then the root port selection, the first root port is there. So root switch. So the root
Hmm.
switch selection also like might change after some second, like 30 seconds, like for
Yeah,
the
there is a
switch.
possibility. See, so let's say that,
Okay,
yeah, let's say that, for example, for previously, let's say that this interface, it decided that this interface was a block port and this interface was supposed to be root port is black. This interface was supposed to be root. Okay.
okay,
Then suddenly a new BPD is received. Okay, new BPD is received where it has a better MAC address or a lower MAC address or a higher MAC address, and the cost is different. Everything. As I said, this root port election, block port election, designated port election is completely based on where your root switch is sitting and what is the cost to reach the root switch, what is the neighboring switch's MAC address, okay, what is my cost to reach those MAC addresses, etc. Based on different criteria. Like, these different port roles are decided. Okay, so for one instance, okay, for an instance, it might have decided that after my 30 seconds has elapsed, okay, in my 15 seconds, I will say that these two are block ports and this is root port. Suddenly, there is a new BPDU that is received. So in that 15 seconds, it will change its decision. It will immediately change its decision. It will say, okay, now the root port or the root port is different. Okay, now this is supposed to be a root port. This is supposed to be, sorry, this is supposed to be a root port and this becomes a block. So every time a new BPDU is received, of anyway, when will a new BPDU be received? When some switch says that it is the root. As I said, BPDU is generated only by the root switch. You can see it over here. I've clearly mentioned it is generated only by the root switch. Okay, so let's say that for some reason 5 decided this is my current scenario. 2 block ports, and these are the 2 block ports, and this is the root. Suddenly, why it has made this decision based on the BPDUs that it received. Okay, now imagine that switch 1 or whatever decision switch number 5 has made was based on the BPDUs that it received from these 4 switches. Okay, among these 4 switches, 5 made this decision. Okay, now when these few switches made their decision, okay, obviously they will forward their BPDUs to switch number 5. Then switch number 5 will again make that decision. And please remember, in this 30, do not forget about the speed at which they are exchanging these BPDUs with each other. Okay, so in that 30 seconds of time or even 15 seconds of time, the rate at which these switches are exchanging information is extremely high. Okay, so you may think 15 seconds or 30 seconds for 50 switches is very less, but no, it is quite high. Even a 2 Mbps link can send data very quickly. Okay, it can receive BPDUs very quickly, it can process those BPDUs very quickly and make that decision very quickly as well in that 15 seconds. So I hope I am able to answer your question. I'm not sure.
So let me clear it so I understood or
Yeah.
not. So what I understood is even if any number of switches there, even if this is 10 switches, even if it's 20 or 50 switches, okay. In the beginning, the process starts, we connect all the switches and immediately first BPDU, everybody will start sending. Okay. Based on that messages, one root switch will be decided. Okay.
Correct.
Root switch. And suppose a 50 or 100 switches network, by the time the root switch is decided, it will be 30 seconds, whatever size of the network. So after the root switch is selected, then only the root switch will send BPDUs. So this root switch selection will take 30 seconds, whatever size the network. That's what was my doubt. So it is a 50 switch, 100 switch, or
Let's
any
say,
switch.
no. Let's say that there are 100 switches, as you said. Okay. Let's say that there are 50 switches on the, let's say 50 switches on one side and 50 switches on same side. And in total, there are 100 switches in the network.
100 switches, yeah.
You connect them together and then you start the spanning tree protocol. Okay. Obviously, in 30 seconds, the whole network will not be able to decide who is going to be the actual root switch. There will be flow of BPDUs among themselves. Okay. As the new data keeps updating, okay, the new root switch, let's say that among these 50 switches, okay, two of them decided to be the root switch. Okay, two of them decided to be root switch. Okay, so let's say 25 switch over here. That decision was made very quickly among those 25 switches. And here also there were 25 switches which made the decision who is going to be the root switch. Now, between these two switches, again, they will exchange. They are exchanging BPDUs. So one of these two switches will come to know that I cannot be the root switch because one of them has a higher or a better MAC address or a lower priority or a lower MAC address, whatever. Okay. And that BPDU will be exchanged on the other side as well. Okay. So here also among these 50 switches, it will take some time. I'm not saying that it will take 30, like, no, all the 100 switches. Sorry, all the 100 switches, the decision of root switch will be decided in 30 seconds. It may exceed. Every switch takes, even there are 100 switches in the network, even one switch will take time to move its interface from a disabled state to either a root port or a block port or designated port in 30 seconds only. No matter how many switches are
Okay,
there,
now
it
got
can be
it.
100,
Yeah,
it can be
now
200.
got it.
Every switch is taking its own sweet time of 30 seconds. Sorry. Every switch takes its own sweet time of 30 seconds to make its own decision. It can be a root
Yeah,
switch.
it's clear
It
now.
can
So
be a
now,
non-root switch. Anything can happen.
non-root switch can be anything. And the whole network changing, it might take any time. We are not sure about that. It
Yeah.
might be 30
The
seconds,
whole
might be 60 seconds, might be 1 minute also.
exactly.
Got it. Okay.
The, okay. To create a loop-free environment, 30 seconds may be less. I hope now I have answered your question.
Yes. Now it is now it is clear. Yeah.
For a 100 switch network, loop-free environment may take more than 30 seconds, obviously. Okay, it is obvious it may take more than 30 seconds. But every switch will make its decision to move its interface from a disabled state to forwarding or a blocking state in this 30 seconds only. Clear?
Yeah, fully clear now.
Yeah. Hey, hi, Naresh.
Yeah, hi sir.
Okay. Now this. So we have 4 states. One is disabled, listen state, where the switches are sending BPDUs. They're receiving BPDUs for 15 seconds. Then after this 15 seconds, the interfaces move to a learning state where whatever BPDUs are received, they start to make that decision. Am I a root switch? Am I a non-root switch? Based on the root switch or a non-root switch, they decide the port roles. Once this 15 seconds is elapsed in the learning state, then the interface goes into the forwarding state or block state based on the criteria that we have discussed earlier. Okay. Now, imagine, as I was saying, switch number 1, switch number 2, switch 3, and switch number 4. Okay. Now I connect a PC over here. I connect a PC over here. So when I connect a PC for switch, again, this is a connectivity. It does not matter what device is it connected to. Is it a PC? Is it a switch? Is it a server? Is it a printer? Is it an IPTV? Is it a networking device or is it a non-networking device? It does not know. It only knows that there is a connectivity on this interface. Okay. Now, imagine I connected a PC over here. I connected a PC over here. Obviously, for a PC, okay, I do not want this PC to wait for 30 seconds. Okay. Imagine that there was no connectivity earlier. Okay. This is the root switch. This is the root switch. This is the root port. Okay. And for switch number 3, this is the root port. Okay. And this is the block port. All right. And this is designated port, designated port, designated port, and designated. Okay. Now I connect a PC over here. The moment I connect a PC over here, the switch immediately identifies that there is a connection over here. So it will take, previously there was no connectivity. That means it was in the disabled state. It was in the disabled state. The moment you connect a PC or the moment you connect a wire, the moment you plug a wire into that interface, it enables spanning tree on that interface, and that interface goes from disabled state to forwarding state, and it takes 30 seconds for it. It will stay in the listening state for 15 seconds. It will stay in the learning state for 15 seconds. Then it will move into the forwarding state.
But one
So,
doubt here.
yeah.
One doubt here. So it is connected to this other port to the PC, but the thing is, it will not receive any BPDU. The PC will not send any BPDU. So, how it will know that it will wait for 30 seconds? But this side, other if it is connected to any switch, the switch's connection it will send BPDUs. But connecting to PC, it will not send BPDUs. How? Why it will wait for 30 seconds there then?
Exactly. See, that's the thing. When PC is not sending any BPDUs, what's the point for this interface to wait for 30 seconds? For a switch, this is an interface. Okay. Switch does not know what kind of device is connected over here. Okay. It does not care if I receive a BPDU or not. All the switch know is that there is a connection on this interface and I have to move it to the forwarding state. And to move it to a forwarding state, the spanning tree will take 30 seconds for it. And as you just as you just rightly pointed it out, why should the PC wait for 30 seconds? Okay, or why should the switch make the PC wait for 30 seconds? It's not needed, right? So to solve this problem, or imagine us, our Wi-Fi connection. Okay, we enabled Wi-Fi on our phone. Okay, and imagine you sitting for 30 seconds for the Wi-Fi to be connected to your phone. You lose patience. Okay, you immediately lose patience. Why is the Wi-Fi not getting connected? You go to the Wi-Fi modem and check if all the lights are green or not. Is there any problem? Is there a loss of signal, etc.? We don't even have that patience of 30 seconds. Okay, so why would I want this PC to wait for 30 seconds in order to start sending data? Because until and unless this interface moves into a forwarding state, it cannot receive data, nor it can send data to the PC. I hope this is clear. Is this scenario clear?
Yes, yes.
Yeah. So for that purpose only, it is recommended that if you are connecting a switch interface, please listen to this very carefully. if you are connecting a switch interface to an end device like a PC or an IPTV or an IP phone, whatever. Make this interface as a port fast interface or enable port fast on this interface. Enable port fast in this interface. So when we enable a port fast interface or when we configure a port fast on a switch interface, it will immediately move into forwarding state. It will not go through this 30 seconds of time. It will immediately move into forwarding state, and this PC can immediately start to send data and receive data as well. So we enable port fast on that particular interface. So this is one of the spanning tree feature. And that feature, one of the feature name is port fast. And it is always recommended to enable port fast on those interfaces where you are sure an end device is going to be connected. Where an end device is going to be connected. Okay. So I will show you in tomorrow. Tomorrow, what's tomorrow? Tomorrow is Friday. Yeah. Okay. So I'll show you tomorrow when we are doing the lab that the moment you enable port fast on a switch interface, it throws a warning saying that make sure that you are connecting this port fast interface to an host device. Okay, it throws a warning because it is always recommended and it's the best practice to connect a host device to a port fast enabled interface. And why so? We'll try to understand that now. Why is this warning created? Why can't I connect a switch onto this interface, a port fast enabled interface? Let's try to think from that perspective. I hope
Okay, one
you
more
are,
doubt. Okay, one
yeah,
more doubt. So
yeah.
we waiting for this 30 seconds thing to change that port to this one for the PC connected that port, right? So what is that timer? We use the dead timer, or that will come once the topology is ready with the root switch there, and then if any port gets blocked, that time only the dead timer will come, or this time also it can come, or this time it will not come, the
See,
dead timer on this thing.
see, over here it is sending hello BPDUs. It is
Okay.
sending hello BPDUs, but because it did not receive any hello BPDUs from that side, the dead timer does not even matter for it.
Okay,
Okay,
okay, that
I
okay.
am continuously sending hello to you. Okay, I'm expecting a hello back. If I receive a hello back, then only I will look for a dead timer.
Okay, first time if you receive, then second time you look for that thing. If you don't receive, that's the problem. But if you never received, you will not care about that thing.
Exactly,
Okay.
because PC will never send a BPDU. Okay,
Mhm.
so until and unless there is a BPDU coming from the other side, until unless there is a BPDU coming from the other side, there is no point of looking for a dead time. Okay,
Mm.
if you
Okay, okay, it was for receiving thing, right? Yeah.
exactly. So it's like I am speaking continuously. Okay, or it's like, for example, like I'm practicing my speech. Okay, for example, just imagine that I'm practicing my speech. I'm practicing my speech in front of a wall. I'm practicing my speech. Okay, or I'm practicing my speech in front of a wall. Obviously the wall is not going to reply. The wall is not going to ask me questions, and I'm speaking confidently. Until unless the wall starts to reply, that's where it will freak me out. Correct. So when you are speaking to someone and that person is not responding, you will keep on speaking. And if the person replies, that is where you have to listen to what that person is speaking. And if that person stops speaking to you, you have to make sure he is replying to me or not. And if he is not replying to you, you consider him dead. That is how Swiss thinks. If I am sending BPDU And if I'm not receiving a BPDU, why would I care about dead time? I'm continuously sending my BPDU. And if for some reason there is a switch connected here, he will send me BPDUs, and then we'll start talking to each other. And when we start talking to each other, that is where when I will care about the dead time. So over here, when I'm not receiving a BPDU, why would I care about a dead time? Got it?
Yeah, got it.
Now, as I said, the port fast interface is always recommended. And when you enable port fast on a switch interface, it will throw a warning saying that make sure that you are connecting a host device on this port fast interface. And why is that warning thrown? Let's see that from an example. Switch 1, switch 2, switch 3, switch 4. And let's imagine that there is another network over here with 4 switches, switch 5, switch 6, switch 7, and switch 8. Okay. And in this network, switch 8 is the root switch. Okay. Currently, this is the root switch, and we have a block port over here. Okay. And I enabled port fast over here. Okay. I enabled port fast over here. Okay. And we are human. Obviously, we are human, and we may make mistake. And because of that mistake, I connected a switch over here. Okay. Now, this interface was supposed to go from disabled state to forwarding state, and it has to go through listening state, it has to go through learning state, because in the listening state it will send BPDUs, it will receive BPDUs as well. Correct. But because I enabled port fast, it is not sending BPDUs, it is not receiving BPDUs, it directly moved into a forwarding state. That means the data over here can immediately be sent to this network, will immediately be forwarded to this network. Or even worse, for some reason, let's say that switch 8's MAC address, switch 8's MAC address is lower than this root switch, is lower than that of switch number 1. Switch number 1 will lose its root switch status. It will lose that position, and the whole network will change. Your topology will change. Your root ports will change. On all the non-root switches, the root ports will change. Probably this now will not be a block port. Some other interface on some other switch may be a block port. Obviously, now switch 1 will not be a root switch. It is going to be a non-root switch. Correct. Now, based on this root switch, now this network and this network will decide which of these interfaces will be a root port, which of them will be a block. Okay. And even worse, this may be a network of an intruder. This may be a network of an intruder. He can send data to your network. Right. So that is why it is always recommended. It is always recommended to connect port fast on host devices and not on switch interface. Okay. It is always recommended. Okay. It may not be for an intruder. It may not be from an intruder network. However, I do not want, for some reason, I do not want the data that is running between these switches to go into some other network. But by mistake, I forwarded this data into this network as well, which I was not expecting. So as I said, we are human, we can make mistakes. Okay. Now let's imagine we did so. Okay, we connected a switch interface. We connected a switch to a port fast network. So it will immediately start to forward. Okay. Now, even if you do not have port fast, even if you do not have port fast enabled, even then this two networks will communicate with each other. Why? Can you guys tell me why will it communicate? Forget port fast for now. From a normal switch perspective, if I simply connect switch number 5 and switch number 2, they will start to communicate. Why?
Because of spanning tree.
Exactly, because they both will exchange BPDUs. They both will exchange BPDUs. And when BPDUs are exchanged, obviously there will be flow of data. There will be flow of data between the two networks. Okay, which for some reason I do not want, but for some reason it happened. Okay, so the first and foremost rule, again, do not ever connect a non-host device to a port fast interface because it will immediately start forwarding data. It will immediately move into forwarding state and it will start to send data. That is why it's not recommended. Second thing, even if port fast is not enabled, the two switches will start to talk to each other. Okay, we cannot stop it because that is this switch's work, or that is how spanning tree is designed. If you connect two switches together, they will exchange BPDUs with each other and they will start to forward data. That is how the switches are designed or spanning tree is designed. Now to stop this, there are two methods. To stop this, there are two methods. Okay, first is called as a root guard. Root guard. Now imagine this as a root switch, and this guy is also a root switch over here. I connected switch number 5 to switch number 2. What will happen? They both will start to exchange BPDUs with each other. Where switch 5 will say who is the root switch in his network. It will say switch number 8 is the root switch. This guy will say switch 1 is the root switch. Correct? That is how they will exchange BPDU. Now let's imagine that switch 8's MAC address is lower than that of the switch number 1. Okay. Switch 8's MAC address is lower than switch number 1. So what will happen? Switch 1 will lose its status as root switch, correct? And the whole network will change based on switch 8's location. Who is going to be non-root switch, which will be a root port, block port, designated port, etc. Everything will change, which I did not want. So to avoid such mistakes, okay, what we basically do is on switch number 2 or on switch number 5, anything on switch number 2 or on switch number 5, we enable root guard. Okay, what root guard does is it will look for lower priority, or it will look for lower MAC address in the BPDU. Lower priority and lower MAC address than the current root switch in the incoming BPDU. Okay, let me repeat this again. Root guard looks for a lower priority and a lower MAC address in the incoming BPDU. Okay, if it finds out that the incoming BPDU's root switch, has a lower priority or a lower MAC address, what it will do, it will block this interface. It will immediately block this interface. Okay, when it blocks this interface, it will not receive BPDUs. It will not receive BPDUs. It will not send BPDUs also. So what happens? Your switch number 1 will remain as a root switch, and your existing network, this is your existing network, it remains safe. Clear? Because of the root guard feature. Any question with root guard?
Yeah, it's clear actually.
Clear. Now, okay, now root guard is enabled. Root guard is enabled. Okay, let's say that 8 is the root switch. And for let's imagine that this is an intruder's network. This is an intruder's network. Okay. Let's imagine 8 is the root switch, but 8 has a higher MAC. This time it has a higher MAC. Previously it was a lower MAC. Now it has a higher MAC. If it has a higher MAC and when switch number 5 sends the BPDU, root guard is not going to work. Why? Because root guard is taking lower priority and a lower MAC address. But in this case, this root switch has a higher MAC address. When it has a higher MAC address, this root guard does not work. And when the root guard does not work, these two will exchange BPDUs and eventually this network gets merged with this network. They will eventually start to exchange data. Is this problem clear? We have a problem over here. Is this problem clear?
So one side we blocked, but still started like one BPD guard is there, but still started flowing because this side the root was more, and left side
Yeah,
the
yeah.
root is
Here
less.
you still have the root guard enabled. You
But
have the
still
root
other
guard
side was
enabled.
not less, so it started flowing in.
Exactly. Why? Because the root guard checks for a lower MAC address and a lower priority, which this switch did not have.
Oh, then anyways that information will go out. Either that one has a low
Exactly.
or high. So no use of
Yeah.
the root guard, right? It's just
No, no, no,
only
no.
for one point it is stopping
If
if
it
the other side
if
is.
it is if this root switch has a lower MAC address,
But then only it will
if it is
stop.
as
Otherwise it will not.
then only it will stop. It has a lower MAC address than the current root switch. Then only it will stop.
So then it is
But if it
useless, right? We should keep something. Why they kept it to commands like that? It should be
exactly,
like you have to.
yeah. So this is a
Anyways, it
loophole.
is affecting the other side.
Correct. This is a loophole. So for that purpose, we created something called as a BPDU guard. BPDU guard. And what we do, we enable BPDU guard over here. So irrespective of the priority, it can be low priority, it can be high priority, irrespective of the MAC address, it can be a low MAC address, it can be a high MAC address, it doesn't care. It's a BPDU. The moment it receives a BPDU, it will block this interface. It will immediately block this interface. It doesn't care if that BPDU has a lower priority or a lower MAC address or a higher priority or a higher MAC address. I don't care. It's a BPDU. I will block it. So here, root guard is basically looking for a lower priority, lower MAC address so that the current root switch is safe. But a BPDU guard is looking for a BPDU. It is not looking for a lower MAC address or a lower higher MAC address. It is looking for a BPDU. So if it receives a BPDU on that interface, it will block it. It will immediately block it. So instead of using a root guard, I personally feel BPDU guard is the best option to go for.
But then
BPDU
that
guard is
port
the
fast feature, what about that? That also needs to be
okay.
there, or this BPD guard is
See,
enough for
okay.
everything?
No. Port fast. Port fast basically helps you move from disabled to forwarding state immediately. It completely ignores that 30 second of timer, 30 seconds of forward delay time. Okay.
Yes, right.
And you need port fast where you have hosts connected, like a printer or a PC or an IP phone or an IPT. You need port fast there. And
Okay, and this one,
since you are the admin, you should make sure that you are connecting host devices on a port fast interface. And
Yes.
if you are not sure, that on the port fast interface in future a switch may be connected or a networking device may be connected, it is best to enable BPDU guard there as also. It is best to enable BPDU guard also. Or the even best practice, or as a best practice, enable BPDU guard on all unused ports. Best. Enable BPDU guard on all unused ports. Here only two interfaces are being used. The rest of the interfaces enable BPDU guards. So in future, even if anyone tries to enter your network by connecting a switch, and over here there is a PC, if someone tries to enter your network, this switch will eventually send a BPDU, and this BPDU guard interface will detect it and it will block the interface. And the only way to come out of this blocked interface, it can be a root guard blocked interface or it can be a BPDU guard blocked interface. The only way to come out of that blocked interface is manually shutting down the interface first and then doing a no shut. Manually shutting down the interface, then doing a no shut of the interface, then only this interface will be unblocked. Okay, root guard also blocks the interface, BPDU guard also blocks the interface. And the only way to unblock this interface is to manually shut the interface by going into the interface. Let's say interface fast Ethernet 0/0, then you will write shut, enter, and then you will write no shut, enter. It will unblock the interface. Okay, so it is recommended to always have BPDU guard on all the unused interfaces, so that in future, if anyone tries to even plug in something, okay, and by chance there is a switch connected which will send a BPDU, it will block it. Again, there is a loophole. Again, you may ask or cross question over here, if this is a switch, okay, on all these interfaces, the BPDU guard is enabled. For imagine these are 4 interfaces, and on all these 4 interfaces, BPDU guard is enabled. But instead of connecting a switch, I connected a PC. Obviously, PC is not going to send a BPDU, so PC will start to forward data. Eventually, this switch will start to receive. That's a loophole, basically. Even if you have BPDU guard enabled, the switch or the PC is still able to send the data. That's a loophole, but that's something we cannot everything cannot be done by a switch. There should be some advanced security protocol be put in place in order to avoid such kind of intrusion. Okay, that's a completely different discussion about security. Okay, any question till here?
No, it's clear.
Naresh, any question from you?
No, sir. It's clear.
All right. So tomorrow we'll look into the practical of what we have learned. Okay, these states, we look into the practical of these states, listening state, forwarding state, etc. Okay, then we will look into the port fast, root guard, and BPDU guard as a practical. Okay.
Okay, sir.